In this video, we're going to present the answers to Activity 6-1, thermocouple voltages. Modern thermocouple calibration instruments automatically adjust to maintain a 32 degree Fahrenheit 0°C ice point reference for both reading and simulating thermocouples. Although this is automatic, it is important to understand the basis for these automatic operations. The values shown are in millivolts, referenced to the 32 degrees F or 0 centigrade millivolt value. The voltage produced at the ambient temperature must be added to the voltage at the elevated temperature. I like to think of thermocouples as little batteries, and they're talking about the ice point at 32 degrees F, so that's like our ground. And you can see here, right here in the chart, at 0 degrees C we have 0 volts. So that's kind of like our ground. And at any elevated temperature above that, we're going to get a voltage. 90 degrees gives 4.726 millivolts, and that's referenced to here, to this 32 temperature. Now this gets more complicated when the thermocouple junction is not at 0 degrees C, and that's what this is all about. So you can imagine, let's draw a little picture here. We've got the hot junction of the thermocouple, and it comes over to a block which is typically copper or something and maintained at constant temperature. So these might be copper wires. Over here I'm going to measure the voltage. And here, these are dissimilar metal wires, and the metal depends on what type of thermocouple it is. So here's the hot junction. This is the reference junction. And this might be at 70 degrees Fahrenheit. Let's say that it is. So the voltage that's actually measured here is not this whole voltage. It's only this little bit of voltage here. This is what we measure. Now, what we need to know is the temperature of this block. Then we can add back in this missing part. So that's kind of how this works. So in this case, we'd say, well, 70, we got 3.650 millivolts. And if we actually measured, our measurement would be equal to the 4.726 minus the 3.650 millivolts. All right, let's look at problem number 1. Given an ambient temperature of 0 degrees C and a voltage reading of 1.277 millivolts, the hot junction temperature is, this is an easy one because we don't have to deal with any offsets, and that's why I have, so really this is 0, so there's the 0 degrees C part, plus 1.277, which is what we measured. It's equal to 1.277, and when I go look that up on the table, let's see if we can find it. There it is right there. So that's 25, so the answer is 25 degrees centigrade. Okay, let's look at number 2. Given an ambient temperature of 15 C and a voltage reading of 4.181 millivolts, the hot junction temperature is, so if we do this on our kind of number line way of doing it, thinking of it like a battery, so we've got 15 degrees C, 0, and then some unknown temperature up here. We know that this bit is giving us 4.181 millivolts. And now I can just go on the table and look and see. If we were to measure from 0 degrees C all the way up to the temperature, what would the millivolt reading be? That's what we need to know. So we've got 15C. Let's go look up 15C. Here's 10, 15, 0.762 And so all we have to do is add 0.762 to our measured value, 4.181, and we get 4.943. So I go on my table looking for 4.943. That's the one we want right there. And that happens when the temperature is 94. So the answer to number 2 is 94. Given an ambient temperature of 20 C and a voltage reading of negative 0.154 C, so for 20 degrees C, that's 1.019 millivolts. So here I've got plus whatever we measure, and I get 0.865. And when I go to look that up, 0.865, I get 17 degrees C. Number 4, given an ambient temperature of 25 degrees C and a voltage reading of negative 2.173 millivolts, the hot junction temperature is. So I look up the millivolts at 25 C and I find that it's 1.277. I'm going to add that to the measured value and I get negative 0.896. So that's less than 0. That's going to be a below 0 degrees C temperature. And when I come up here to the table and look up minus 8.96, I find it right here. So that happens at minus 18 C is where that happens. Okay, here's the last one, number 5. Given an ambient temperature of minus 10 centigrade and a voltage reading of 5.336 millivolts, the hot junction temperature is. Okay, so I look up minus 10 and I find that at minus 10 C we get negative 0.501 millivolts. Now I'm going to add that to the measured value and I get 4.835. And when I look up 4.835 on the table, I find that it's 92. So that's the answer to that one. All right, that concludes activity 6-1.